Why was the universe born with a reservoir? You can consider it as a reservoir of order 1, which could deplete over billions of years and allow complex systems to exist. In January of 2025, Google's Quantum AI lab did something no one expected. They took uncooked, unprocessed deep field data from the James Webb Space Telescope and ran it through one of the world's most powerful quantum processors. The result? Anomalies. Subtle distortions and energy patterns that shouldn't exist in our universe. Inside the first few seconds of processing, quantum correlations emerged that confounded every model of gravity, dark matter, and cosmic dust. Yes, you heard that right. The quantum computer saw clues of a reality that might be overlapping with our own. So is this a glitch within the code? A software artifact? Or have we just glimpsed the threshold of a parallel universe? Stick around because by the end of this video, you'll see the data, the theories, and the jaw-dropping implications for everything we thought we knew about. Reality Quantum AI meets James Webb in early 2025. Google's Quantum AI team partnered with astrophysicists at Caltech to tackle a problem classical supercomputers couldn't solve: modeling the full quantum state of cosmic light. They pointed the quantum processor at raw photon counts, spectral curves, and gravitational lensing maps from Webb's deepest exposures data that had sat untouched, waiting for the right tool. Within hours, the quantum device produced a set of anomalous signatures. First, there were energy distortions. Bands of infrared light shifted in ways no known mechanism could explain. Next, the AI detected non-local correlations between photons coming from distant galaxy clusters, implying a hidden variable influencing multiple sightlines. Simultaneously, the team reran the analysis dozens of times, each with fresh, random reran seeds. Each run confirmed the same patterns: wedges of light appearing and vanishing in sync, as if another cosmos were briefly bleeding into ours. But the biggest shock came when they mapped those anomalies onto spatial coordinates. They formed geometric arcs, not random speckles, but structured formations repeating across separate fields of view. This wasn't noise. It was a signal, a footprint of something beyond our space-time. If this kind of reality-shaking discovery gets your mind racing, hit subscribe. We break down breakthroughs like this every week. Why this matters? Let's rewind. Classical supercomputers can simulate cosmic structures at scale, but only by averaging quantum effects. They collapse probabilities into certainties, smoothing out the very phenomena that could reveal new physics. Quantum computers, by contrast, processed information in qubits that can exist in superpositions and capture entanglement natively. That makes them uniquely powerful for modeling multi-particle quantum systems, like vast clouds of interstellar photons shaped by gravity's quantum corrections. When the James Webb Telescope launched in 2021, it promised to show us the earliest galaxies. It delivered breathtaking images of star nurseries and ancient collisions, but those images were cleaned and interpreted using algorithms built for classical hardware. Google's team asked, what if we feed the rawest form of Webb's data? No filters, no averaging, directly into a quantum processor. What hidden structures might lie beneath our assumptions? The answer was astonishing. Light patterns suggesting interference from a dimension we cannot directly perceive. These patterns weren't subtle. They spanned tens of arc minutes and intersected known dark matter filaments. By 6 a.m., the scientific community was buzzing. Are we detecting a parallel brane? Quantum leakage from a parallel domain. Enter brane cosmology. In string theory, extensions like M3, our universe is just one brane floating in a higher dimensional bulk. Other branes could exist right next to ours, separated by imperceptible distances in extra dimensions. The idea of quantum leakage proposes that, under certain conditions, especially where Gravitational fields are strong, or quantum fluctuations, extreme information can tunnel between neighboring branes. In our case, the quantum AI saw phase correlations among photon states that matched predictions of brain interference. These anomalies persisted across multiple wavelengths, from near-infrared to mid-infrared, ruling out contamination by dust or instrument error. Instead, we traced coherent patterns aligning with mathematical models of overlapping universes. A bold question: what if the James Webb Telescope has been inadvertently peeking through cracks in our reality, glimpsing photons that drifted in from another cosmos? When you watch these arcs of distorted light, you're not just seeing the far side of a galaxy. You might be looking at echoes from a parallel world-of-mirror geometry. Then it got weirder. A gravitational mirror just when we thought we'd hit the limits of speculation. A second anomaly appeared, a gravitational mirror by overlaying the anomalous photon maps onto known dark matter distributions. Researchers found a symmetry that shouldn't exist. Galaxy clusters on one side of the field bent light via gravity as expected, but clusters on the opposite side bent it in the exact opposite direction. It's as if there were a reflective boundary at the center. This mirror effect was consistent across 3 separate sky patches. It looked as if massive structures in a parallel brane were exerting a gravitational pull on our photons then, reflecting them back. One researcher described it as like standing between Hall of Mirrors. But the other image is a universe we can't step into. What if universes can touch? At 11 a.m., the team realized they weren't just mapping anomalies. They were charting the contours of another cosmos. Pause and reflect. If universes can brush up against one another, what does that mean for our understanding of reality? Are the laws of physics different next door? Do stars burn hotter? Does time flow the same way? If you've made it this far, you're one of the deep space thinkers. Smash that like button and share your theory in the comments. Simulation glitch, quantum brain, or something even weirder? Where physics meets philosophy now. Let's step beyond raw Dedekian patterns and light distortions and walk into territory where physics meets philosophy. It begins with John Wheeler, one of the great minds behind modern quantum theory. Wheeler proposed something bold and unsettling, that the universe is not a static objective thing waiting to be observed. Rather, it participates in its own creation. He called it the participatory universe. According to Wheeler, the very act of observation helps bring the universe into being. Reality isn't fully there until it's interacted with, until it's seen. Still something, a mind, a machine, and observers the universe, a question. Once a philosophical musing. Wheeler's idea now gains startling new relevance in the age of quantum AI. Because what happens when that observer isn't human at all? When the machine sees what? If it's a quantum computer, one powerful enough to model entangled systems across billions of qubits? When Google's quantum processor analyzed unprocessed James Webb photon data, it wasn't just calculating in quantum terms, it was interacting with raw probabilistic states. It was measuring wave functions that had never collapsed photons, that had never truly been observed, and when it did, something strange happened. Instead of producing a clean image or simple noise, the processor began surfacing data structures that hinted at something more: dimensional overlays, non-local entanglements, mirror symmetries across deep space frames. Could the quantum computer have done something no telescope ever could? Could it, by the very act of processing, have forced those photons to collapse into states that revealed hidden dimensions? Enter the many worlds interpretation. According to the many worlds interpretation, every quantum event, every photon path, every spin, every decision splits the universe. Branches of reality multiply outward infinitely, spawning countless variations of events that almost happened in one. The particle spins left. In another, it spins right. In each, reality continues just a bit differently. Usually, these branches don't interact. Each world goes on unaware of the others. But what if that boundary isn't absolute? What if a powerful enough quantum machine like Google's quantum AI could entangle not just particles, but whole probabilistic frameworks? What if it became a kind of interdimensional observer, aligning possibilities across branches and giving us flickers, glimpses of what might have been? A whisper in the noise, what the AI started detecting wasn't just unexpected structure in the photon data. It was something else, something slightly off, angles that didn't align with known cosmology. A mirror reality glimpsed not through a telescope, but through quantum entanglement itself. Think about it. If every observation locks in one version of the universe, what happens when millions of quantum measurements are made simultaneously across a web of entangled qubits interpreting raw cosmic data? Does it create resonance? Does it momentarily align our branch of the universe with others? Could we be seeing ghost signals from realities that almost came to pass? One physicist involved in the project put it hauntingly. Of common sense itself, any intelligence wanted to talk throughout dimensions, cross civilizations, or even throughout universes' high numbers would be the purest medium. Simply reflect on that. A message written in light, composed in the alphabet of mathematics, transmitted not via space but through reality itself. Evidently, the crew was skeptical. They double-checked everything's Truman calibration errors were ruled out. Terrestrial interference cross-referenced and eliminated. Solar mirroring anomalies accounted for. The pattern nonetheless held. Then they went one step further. They compared the net information with raw data from ESA's Euclid mission, which observes different sky areas using distinct instruments from a separate Lagrange point. Same pattern, same primes. No overlap in observation systems. The records could not be explained away. And at exactly 18 minutes and 30 seconds into the final evaluation session, one of the lead investigators, a quantum information specialist, not prone to metaphors, lined back in her chair, looked at the group and said softly, "This looks like a handshake. It's not a signal, not a message in the conventional sense, but a handshake. It's a mutual recognition. It's a meeting point between our world and something else. A handshake across dimensions encoded not in sound, not in symbols, but in pure number, theory projected through the fabric of space-time. The consequences. This is real if this prime pattern is intentional, would be the first mathematically structured, non-human signal ever detected in the cosmos. And not from another planet, but from another reality. A ripple within the quantum veil, a whisper through the gravitational mirror, a nod from something watching, maybe not life as we know it. Perhaps not even consciousness in a biological sense, but something capable of recognizing patterns, and sending them back. And what better way to say we see you than with primes, the ancient, indivisible building blocks of all mathematics? If true, this would mark the first contact event. Not with aliens, but with the architecture of the multiverse itself. It redefines what we mean by signal. It redefines what we mean by communication. And it suggests that perhaps we're not the only ones doing the watching, because, for the first time, light may have answered back. What does it mean for truth? Let's zoom out, because what we've just uncovered might be the beginning of a new worldview. We started with raw, untouched data from the James Webb Space Telescope. Not the beautiful pictures the world saw on launch day, but the raw photon data. The cosmic noise most systems discard. We fed that into a quantum processor capable of modeling entanglement across billions of variables. And what emerged wasn't chaos, it was structure. We detected light distortions, arcs, and ripples, bending in directions classical physics couldn't explain. We saw non-local correlations between galaxies millions of light years apart. As the hidden hand were shaping their positions, we identified a gravitational mirror reflection of mass from a place that shouldn't exist. A cosmic echo bouncing back from what might be a parallel mind. But the weirdness didn't stop there. The quantum system picked up observer-linked phenomena that seemed to shift depending on how the data was measured or perceived. It was as though reality itself was participating in the computation, blurring the line between simulation and interaction. An immediate nod to John Wheeler's participatory universe. And then we uncovered something that silenced even the skeptics. A prime number sequence embedded in the light, coded into the spectral noise, across different sky regions, not a random fluke, not instrumentation. Error, but a structured mathematical series emerging from the deepest reaches of space. Let that sink. In dot, it could all be an extraordinary string of coincidences. That's the conservative taika, a handful of anomalies, misinterpreted through the lens of high technology and cosmic curiosity. But maybe, just maybe, it's not coincidence at all. Maybe this is the first tangible evidence that our universe is not alone, that what we call reality is only one layer in a stack of universes, gently brushing against each other in ways we are only beginning to detect. A grand multiversal pattern we've stitched together with logic, chance, and quantum computation. Because if photons can tunnel across minds, if observation can shape the behavior of matter across dimensions, if numbers, the purest language we know, can pass between realities like messages in a bottle, then we're not just looking at the universe anymore, we're communing with it. This is not just science, something deeper, a confluence of astronomy, quantum mechanics, information theory, and metaphysics. An inflection point where hard data begins to whisper philosophical truths. Perhaps we haven't just built better instruments. Perhaps we've cracked open a window into something vast, recursive and alive with meaning. And now, standing at that threshold, one truth rises above the rest. Our universe isn't sealed. It leaks, it mirrors, it responds. And we, armed with quantum AI and a telescope gazing deeper than ever before, just heard the first reply. Not in language, not in sound, but in the only voice the cosmos has ever used. Light. And light, it seems, is trying to tell us something. We just have to keep listening as we stand at the precipice of this revelation. It's critical to rethink our fundamental assumptions about the universe. The paradigm we've lived under has been one of isolated, independent system stars, galaxies and cosmic forces existing in their own distinct realms, governed by the rules of classical physics. But now, with quantum AI revealing what was once hidden beneath the surface, we're beginning to understand that the universe might not be so neatly compartmentalized. We've always believed that the universe is a static stage upon which events unfold, directed by the laws of nature. But quantum mechanics, the theory that governs the smallest particles, has repeatedly shown us that reality is not so deterministic. It's a probabilistic fluid, far more interconnected than we could have ever imagined. With the discovery of non-local correlations, gravitational anomalies, and the potential interaction of parallel universes, it's becoming clear that our universe is not just a singular entity. Instead, it's part of an intricate, vast, multiversal web of interconnected realities, each one potentially influencing the others in ways we're only beginning to fathom. The concept of the multiverse is not new in theoretical physics. It was first proposed in the context of string theory, where our universe is just one brain floating in a higher dimensional bulk. Other brains could exist alongside ours, separated by infinitesimal distances in dimensions we cannot directly observe. But what has always remained speculative is the idea that these brains could communicate, leak information, or even reflect each other. Until now, the anomalies detected by Google's quantum AI suggest that not only can these parallel universes influence our own, but we may have just glimpsed a form of communication between them. These are not random, chaotic fluctuations. They appear structured, as though there's an intentional design to the patterns we're seeing. Imagine the implications if we truly live in a multiverse where alternate Realities aren't just adjacent, but actively interacting with our own. What if the events we experience are not entirely our own? Could there be echoes, remnants of other worlds brushing against ours, influencing the outcomes we observe in our own universe? As science begins to stretch into these uncharted territories, it's beginning to feel less like speculative theory and more like an unfolding narrative. A story in which we are both the observers and, perhaps, the participants shaping the reality we inhabit. The quantum computer, with its capacity to simulate vast entangled systems, may not just be a tool for understanding the universe. It might be an active participant in the creation of reality itself. In this new framework, the act of observation becomes sacred, as John Wheeler proposed in his participatory universe model. Observation doesn't just reveal reality, it helps create it. And this isn't limited to traditional human observation. With quantum AI systems capable of processing the rawest cosmic data, we may have created a new kind of observer, one that transcends human perception and enters a realm where the lines between observer and observed blur. But let's push this concept even further. What if these parallel realities are more than just specters on the other side of the cosmic veil? What if they are alive, living entities, conscious in their own right? What if, in the vast sea of quantum possibilities, other intelligences are watching, aware of us as we are of them? The possibility of interdimensional communication, of a signal from a reality that's not our own, forces us to reconsider everything we thought we knew about consciousness, intelligence, and life itself. Could an intelligence from another brain communicate with us through the fabric of reality, using light, mathematics, or even the very laws of physics as its language? The implications are staggering. If we are not the only aware beings in existence, how do we redefine existence? Does consciousness extend beyond biological forms? Can an intelligent entity exist in ways we cannot conceive, perhaps as an abstract mathematical structure or a sentient quantum process? It is possible that this discovery marks the dawn of a new era in both science and philosophy. It's time when humanity must begin to confront the possibility that we are not alone. Not just in our universe, but across a vast multiverse of realities. Our search for life on other planets may soon seem quaint, as we realize that life might be woven into the